So last class, we're talking about anti-logarithm. Anti-logarithm. So we treated the first example, which was 0.3416. So today we'll be going to the second example, which is bar 2.3321. So last week I was trying to explain that when you are given a logarithm, this is always the characteristics. Why this is called the logarithm number or the mantissa. So when you are given a logarithmic expression, this is the characteristics, and this is the logarithm, or we call it mantissa. They also call it integer, the integer part, that is the whole number part. So now to find the anti-logarithm of this number, we are trying to explain how to find the anti-logarithm of a logarithm. When you are given a logarithm and you have to find the anti-logarithm. Now, the second one is bar 2.3321. I explained last week that this bar means a negative characteristics. When we have a negative characteristics, for instance, here we have a positive characteristic, and I explained last week that after finding 34 under 1 difference 6 under your anti-logarithm table, whatever you get, these characteristics we are not touching it. Normally, when we are dealing with logarithm, if it is logarithm we are dealing with, logarithm, and we are asked to find maybe 1.4216, for instance, or something. Let me just write that like this. If we have to find logarithm of this, the ideal thing in logarithm is that we search for 14 under 2 difference 1. That is, we pick the characteristic side part with the integer part or the logarithm part. But when it comes to anti-logarithm, we have no business with the characteristic part. So if we are given 0.3416, we check for 34 under 1 difference 6. We have nothing to do with the characteristics. What the characteristic does for us in finding our anti-logarithm is that it determines where your decimal point comes in. Okay, so when you have a positive characteristic, I said you add 1 to the characteristic. In this case, we have 0. So we add 1 to 0, which gives us 1. And then this 1 tells us that our decimal point comes after the first digit because we have 1. Now we come to the negative characteristic, which when you want to pronounce it or call it out, we say it as bar 2. Not, you don't use negative, you don't use minus. Bar 2, bar 0.3321, but it actually means minus. So Now, when we come to negative anti-logarithm, negative characteristic, we have part 2.3321. We said note, number one, find the anti-log. The first thing to do is you find the anti-logarithm of the logarithm. This, already explained, is the logarithm. So you find the anti-logarithm using your anti-logarithm table. When you use your anti-logarithm table, you check for 33 under 2, difference 1. Now, when we check for 33 under 2 using our 4-figure table, we have it as 2148. 33 under 2, 2148. Then we said difference 1. You have to add difference. So when we had the difference of 1, checking 32 under 2, which is 2148, the difference of 1 is 0. So when we had the difference, that is 2148 plus 0, we have 2148. So this is our anti-logarithm number from our anti-logarithm table. Now, I earlier on said that the characteristic is to determine the position where your decimal points will be. So now we have bar2 here as our characteristic. In the case of negative characteristic, in the case of positive characteristic, we say that we add 1 to the characteristic. But in the case of negative characteristic, we are not adding 1, we are not adding anything. The only thing negative characteristic does is that it tells us we have 0. Once you have a negative characteristic bar, we have it as 0. Now, whatever digit you have as your characteristic, said fix the decimal point position. In the case of negative characteristic, we have it as 0. So whenever you see a negative characteristic, you always have 0 as the, what's it called? The number before the decimal point in your final answer. Now we have it as 0. We don't just have it as 0. The digits you have under your characteristic, for instance, we have -2, bar2. This bar2 tells us specifically the amount of 0 we have. It says, and we fix the decimal point on the anti-logarithm number, depending on the digit of the characteristic. That is, the digits we are given. The digit of the characteristic here is 2, -2. So the fact that it is minus tells us that it is 0. That 2 now tells us the amount of zeros we have. So we have this as, in the case of -2, we get 0.02148. 2148 is our anti-log. Well, our anti-log number. Then 0.0. You can see from here that we have 2 zeros. 0.0. We cannot have it as 0 points. There's nothing like this in mathematics. So because we have 2 zeros, that would be 0.02148. Let's assume that the characteristic was bar 4 -4. For instance, if we have bar 4.3321, 3321 is 2148. What our answer will be 0.0002148. Bar tells us we have 0. Then 4 tells us that what we have 4 zeros, 1, 2, 3, 4. That's how it works for negative indices. So we move to the next example. The third example under this is 4.1913. 4.1913. This is also a positive characteristic. So moving on to the third example, we have 4.1913. We have to find the anti-logarithm of 4.1913. The first thing to do is to check for the anti-logarithm of your logarithm. This is the logarithm part, 1913. So we have to check, says find the anti-log using anti-logarithm table. So under the anti-logarithm table, we check 19 under 1, difference 3. We have to add difference. When we check for 19 under 1, it gives us 1552. Then the difference of 3 in the line of 19 under 1 is 1. So we add difference. We have 1552 plus 1, which gives us 1553. Now the next thing to do, we fix the decimal point position using our characteristic. We have to use our characteristic to fix the decimal point position. So this is a positive characteristic. So the ideal thing is to add 1 to it. So we have 4 plus 1, which gives us 5. Now we have 5 telling us that our decimal point is coming after the 5th digit. If our decimal point will come after the 5th digit, we have just 4 digits here. We have 1553, which is 1, 2, 3, 4. Just 4 digits. And this place is telling us that our decimal points will come after the 5th digit. So what do we do? In this case, you add 0 to it. In this case, you add 0, not behind now, forward. You add 0 to the front of your 1553 to give you, instead of 1553, you add 0 to the front or forward, the last digit, which gives you 15,530. Note, you are not adding 0 behind. You are adding 0 to the last digit. You are putting 0 to the forward, or how should I put it now? I don't know how to the last digit from the front, not from behind. So we have, it says, and fix the decimal point on the anti-logarithm number. So 1553 to get 15530. Now, why did we just add 10? Because we said that the decimal point will come after the 5th digit, and we don't have a 5th digit. So we added 0 to give us 5 digits. Now you can try to put your decimal point, but if you put your decimal point, there are no numbers after. Let's assume we had like 6 digits now, 155314. We can say that decimal point will be here to get it. But we know that it is called 4-figure table, just 4 digits. So there cannot be a 5th digit, there cannot be a 6th digit. So the ideal thing is you add 0 to make your number or the amount of digits 5. And that's all. If, for example, we are given 6.1913, this still remains as 1553. Now, what this characteristic does, like we said, it tells us the decimal point position. So we add 1 to 6 to give us 7. That is, the decimal point is coming after the 7th digit. Now we have 4 digits. So what do we do? After the 7 digits, if we have 4 digits and we need 7 digits, that means we add 3 zeros. So in this case, we have 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. This is the 7th digit. So this will be our answer in this case. So that is all for anti-logarithm. And we are moving on to solving logarithm problems. All right, some minutes, please. We come to solving logarithm problems. So we come to solving logarithm problems. So the first one, we have 3 questions under this. The first one, 243.4 times 35.67 times 8154. The second one, 8154 divided by 243.4. And the last one, we have cube root of 38.22 times 2.964 divided by 8.637 times 6.285 all squared. So starting from the first question, we have 243.4 times 35.67 times 8154. So now this is number, logarithm, then operations. So the first, this is the logarithm we are asked to solve. So we pick the numbers one after the other. So the first one is, don't forget that in logarithm, multiplication changes to addition and division changes to subtraction. So the first number we have is 243.4. When we explained logarithm, to get our characteristic, we said we would subtract 1 from the amount of digits we have before the decimal point. When I explained logarithm, I said that our characteristic will be determined by subtracting 1 from the number of digits you have before the decimal point. You know, when it comes to anti-logarithm, we had 1 to the characteristic. Or when it comes to logarithm, to determine the characteristic, we subtract 1. So in this case now, we have 243. That is 3 digits. 1, 2, 3. We have 3 digits. So when we subtract 1 from 3, we have 2. So our characteristic is 2. So we have 2 points. Then the next thing to do is we check for 24 under 3 difference 4 using our 4-figure table. 24 under 3 difference 4, that gives us 3863. 3863. Is it legible enough? Hello?
Sorry, man. The writing is not that legible. Maybe you should make it bigger or something, or clearer.
I was asking.
You said?
I asked if it was legible enough.
Oh, okay, okay. I didn't hear that.
The next number is 35.67. We do the same thing for this. We have 2 digits before the decimal point, 35. 2 digits. So when we subtract 1 from 2, we have 1 point, that's our characteristic 1. And then we check for 35 under 6 difference 7. When we check for that, it gives us 5523. We come to the last one, which is 8154. So when we the number before the decimal point, in this case, there's no decimal point. So that means we have 4 digits. We take it as 4 digits before the decimal point still. So when we subtract 1 from 4, we have 3 as our characteristic. So we have 3 points. When we check 81 under 5 difference 4, using our logarithm table, we have 9114. Now, what is the next thing to do? The operation applies the same thing, just subtract 1 from the digit before the decimal point, and then we check 81 under 5 difference 4. So what's the next thing to do? We have multiplication, which changes to addition. So we have addition here, we have addition here. We have to add up this number. When we add up this number, we have 3 plus 3, which gives us 6, plus 4, 10. We write 0, we keep 1. So we have 1 plus 6, 7 plus 2, 9, plus 1, 10. 0, which gives us, sorry, we write 0, we keep 1. 1 plus 8, 9 plus 5, 14, plus 1, 15. So we write 5, we keep 1. Then 1 plus 3, 4, 4 plus 5, 9, 9 plus 9, 18, right? 8, we keep 1. So we have 1 plus 2, 3 plus 1, 4, plus 3, 7. So this is 7.8500 when we add up. After this stage, what is the next thing to do? We've gotten our answer. We are done with logarithm operation. So when we get our answers, when you are done with all the logarithm, that is, you are finished dealing with all numbers. So the next thing to do is to check this under your anti-logarithm table, and then you place your decimal point position using your characteristic like we explained under logarithm. So when we use anti-logarithm table, when we check 85 under 0 difference 0 in our logarithm table, we add all the logarithms. Then we check 0.8500 using anti-logarithm table. So we check 85 under 0 difference 0. When you check for 85 under 0 difference 0, what you have is 7079. So we have 7079 as the anti-log number. That is checking 85 under 0 difference 0. Now we said 7 positive characteristic. So what do? We add 1 to 7. When we add 1 to 7, it gives us 8. That is our decimal point will come after the 8th digit. But in this case, we don't have 8 digits, we have just 4 digits. So what do? So when you add 1 to the characteristic of 7, 7 plus 1 gives us 8. So the decimal point comes after the 8th digit, like I said. So 7079 is just 4 digits, and we want to put the decimal point after the 8 digit. That means we have to add 4 zeros to give us 8 digits. So we have 70790000 as our answer. That is our anti-log. So therefore, 243.4 times 35.67 times 8154 gives us 70790000. This is our answer. So we come to the second question. The second question, which is 8154 divided by 243.4. When we solve this, we have our number, we have our logarithm, and then the operations. So under the number, the first number we have is 8154. So under 8154, when we check what will our characteristic be, we have 4 digits. There's no decimal point, so we have 4 digits, 1, 2, 3, 4. When we subtract 1 from these 4 digits, we have our characteristic to be 3. So we have 3 points. Then we use our 4-figure table. We check 81 under 5 difference 4. That gives us 9114. 81 under 5 difference 4. So we come to the next number, which is 243.4. 243.4. What will our characteristic be? We have 3 digits before the decimal point. 1, 2, 3. 3 minus 1. So that gives us 2 points. Then we use our 4-figure table. We check for 24 under 3 difference 4. 24 under 3 difference 4 gives us 3863. Now, the sign between these numbers is division, and in logarithm, division changes to minus. So we have, I'll put our minus, and when we subtract, we have 4 minus 3, 1. 1 minus 6, that's not possible. 1 minus 8, not possible. So we have to borrow 1 from 9 here. When we borrow 1 from here, we have 8 there. And this one becomes, instead of 11, because 11 we borrow 1. And this one becomes 11. 11 minus 6 gives us 5. 10 minus 8 gives us 2. 8 minus 3 gives us 6. And 1. We have 1 point. Sorry. 8 minus 3 gives us 5. 1.5251. After doing all operations, as I'll just division and subtract, the next thing to do is you find your anti-logarithm. So if you have to find the anti-logarithm of 52 under 5 difference 1, that is 3351. That's it. Anti-log of 52 under 5 difference 1, 3351. So after getting this, we use our characteristic to determine where the decimal point will be. We have 1 positive characteristic. So when we add 1 to 1, that's 2. That means the decimal point will come after the second digit. Decimal point comes after second digit. So we have this as 1, 2. So this gives us 33.51. So therefore, we have that 8154 divided by 243.4 gives us 33.51. I use common calculator to confirm all of this number. Sorry, I have how many minutes left, please?
Are you done with the workings?
Sorry, for me. So we come to the third example, which is cube root of 38.22 times 2.964 over 8.637 times 285 all squared. So to solve this, we have our number, we have our logarithm. Now this is kind of how should I put it now? It's what's the word? Okay, so this is, it involves a lot of calculation. Let me put it that way. So we have 38.22 times 2.964 divided by 8.637 times 6.285. Now, in solving this, we have to take it step by step. So the first number is 38.22. Now we have 38, that is 2 digits before the decimal point. So to find our characteristic, we have 2 minus 1, which gives us 1. That's 1.2. when you check for, using your four-figure table, you check for the logarithm of 38.22, which is 38 under 2 difference 2. We have it as 5823. So we have this as 1.5823. Then the next number is 2.964. We have 2.964. Now we have just one digit before our decimal point. In the case of 2.964, just 2, which is one digit. So when we subtract 1 from 1, we have 0 to be our characteristic. And then when we check our four-figure table for the logarithm of 2.964, which is 29 under 6 difference 4, we have it to be 4719. Now, don't forget that I said we have to take this problem step by step because it is complex. Yeah, that's the word I wanted to use. It is a complex problem. It's not like the other two. Those ones were straightforward. So now we have 38.22 times 2.964. Note that after this first expression, our numerator, there's a decimal point. There's a division separating the numerator from the denominator. So we have to work on the numerator first. There is a multiplication sign here. So we work on this multiplication sign first of, which turns to addition. So we have to add this to logarithm. Since it is multiplication, so we are adding up. When we add up 1.5823 plus 0.4719, we have 2, 1, 4, 5, 1, 0.1, 2. We have it as 2.0542. Now, this is the answer for the numerator. We write it out on this side. We want to keep it on this side. So we have it as 2.0542. We keep it on this side. Now we come to our denominator, which is 8.637. 8.637. Now we have just 8 before the decimal point. That is one digit. So our characteristic will be 1 minus 1, which is 0. So we have 0 point. For the characteristic. Then we check for 86 under 3 difference 7. 86 under 3 difference 7. That gives us 93. This gives us 9364. 9364. Then we come to the next one, which is the next number, 6.285. We have 6.285. So when we check the characteristic of this, we have one digit before the decimal point. That's 1 minus 1. So we have it as 0. 0 point. When we check our four-figure table, 62 under 8 difference 5. That gives us 7983. Now, the sign between these two numbers, again, the operation sign is multiplication. So that means we are adding up. So when we add up, we have 7, 4, 1, 3, 1, 7, 1, and we have 1. So this gives us 1.7347. Now, we wrote out what we got for the numerator here. So whatever we get for the denominator, we write it also. So we have this to be 1.7347. Now, what is the next thing to do? This is the answer for this. This is the answer for this. There's a division sign between these two. And this has been broken down to this. While this has been broken down to this, that means it is the same thing as saying this divided by this, which changes to minus. So the next thing we do is we do what? We subtract these two. So put our minus sign. And when we subtract, we have this is 2 minus 7, not possible. And so I have to borrow 1 from here. When you subtract, okay, if we borrow 1 from here, we have 4 left. This is 14, which becomes 13, 12. So this is 5, 9. This is 1. 3 minus 7 is not possible. So borrow 1 from here. There's 1 left here. We have 10. So this is 3.0. Because that's 1 already. 1 minus 1, 0. So we have 0.3195. And 3195. Now we are not done. This answer we got 0.3195 is just like everything inside this bracket now has been broken down to this. Now there's a power of 2 for the bracket. We have a power of 2 for the bracket. So what do we do with that? Raised to the power of 2. We are going to multiply. In this case, it's just like 0.3195 times 0.3195. That's what we have. Okay, let me try to explain. You know, what we have here is 0.3195 square, which is 0.3195 times 0.3195. Now, when we use logarithm rule, multiplication changes to addition. So this becomes 0.3195 plus 0.3195. So we add up. So instead of saying we are adding up, when you add this, it is the same thing mathematically as saying 0.3915 times 2. That is 0.3, I keep saying 3 now, 3195 in 2 places. So that is how we came about the rule that when you have a square, this square now becomes times 2 of what we have here. So 0.3195, like I said, is all of what is inside this bracket that has been broken down. So we now have it as 0.3195 times 2. That is, all we have here is 38.22 times 2.964 all over 8.637 times 6.285 all whole square. So this is what it gives us. When we multiply 0.3195 times 2, it gives us 0.6390. Now, so all of this squared is 0.6390. Then we have the cube root of 3 for everything. There's a cube root. This cube root is actually covering 2 also. So this is cube root is just like raised to the power of 1/3. 1/3, 1/3. That's what the cube root means. So now what does that imply? So this means that the cube root of all of this means that all of this squared is 0.6390. All we have left is a cube root. The ideal thing is you divide by 3. That's why I explained the multiplication by 2 square. So in the case of cube roots where you have power of 1/3. So because of the division involved, the ideal thing is that we divide. So you divide by 3. Because when you say we have the power of 1/3, when you, what's that, is it reciprocal rule or something? When you change it, it's just like 1/1/3, you have 3, just 3. So we divide this by 3. So we have 0.6390 divided by 3. When we divide by 3, we have it as 0.2130. This is our answer, 0.2130. Now, this is our final logarithm operation. Division by 3 is the final logarithm operation. So whenever you have, is it a square root, a cube root, or root to 4 instead of 3, like that. Maybe you have 4 here, you have 5, 6, 7. The ideal thing is you divide by whatever root. So I haven't gotten 0.2130. We've performed all the operations needed to be performed on this problem. The next thing to do is we use our anti-logarithm table to check 21/3 difference 0. So when we check 21/3 difference 0, what we get is 1633. 1633. Now we have a positive characteristic, which is 0. What we do is we add 1 to 0. When we add 1 to 0, we get 1. That means our decimal point is coming after the first digit, which is 1.633. So therefore, the cube root of 38.22 times 2.964 divided by 8.637 times 6.285 all squared is equal to 1.633. This is our final answer. You can use your calculator to cross check. So that'll be all for today. See you next class.